Chapter 5.2 exercises 40 through 49. This section 5.2 has to do with verifying trigonometric identities. And we're going to go over the odd number problems here. And here's problem 41. We have the square root of secant x minus 1 over secant x plus 1 equals the absolute value of secant x minus 1 over tangent x. And what we're going to do is work with the left side and have the left side eventually equal the right side. What we're going to do is take this left side here and rewrite it as secant x minus 1 over secant x plus 1. And what we're going to do is multiply this first expression on the left by the conjugate of the denominator, which is going to be secant x minus 1 over secant x minus 1. Now, I hope you realize that by taking the square root of something over that same something, we're effectively multiplying this first expression on the left by 1. But it's going to help us in simplification. So what that is going to be is the square root of this whole thing. And in the denominator, we have secant x plus 1 times secant x minus 1. Well, that's going to be secant squared x minus 1. And in the numerator, we're going to have secant x minus 1, and that's going to be quantity squared, because we're just multiplying the same thing by itself in the numerator. Well, in the denominator, let's look at this identity. We have tangent squared theta plus 1 is equal to secant squared theta. So if we subtract 1 from both sides here, we have tangent squared theta is equal to secant squared theta minus 1. So knowing that, we can rewrite this expression here on the left as, we're going to write our denominator this time as tangent squared x. And in the numerator, we're going to write the same thing here, which is going to be secant x minus 1 quantity squared. Well, what we can do is, taking the square root of the numerator and the denominator, the square root of this numerator is going to be secant x minus 1, and the square root of the denominator is going to be tangent x. And we know we have to have the absolute value of that y, because we can't take the square root of a negative number, and so that's why we have to have the absolute value. And so that's the verification of the identity in problem 41. Next odd number problem, which is 43. We have the natural logarithm, the absolute value of cotangent x plus the natural logarithm of tangent x cosine x equals the natural logarithm of cosine x. What we're going to do for this one is we're going to take this left side and make it equal the right side. And we're going to use our properties of logarithms. If you have the logarithm, if you add two logarithms together, in this case natural logarithm, it's the same as the multiplication of their product. And so we can take this ln natural logarithm of cotangent x, and I'm just going to go ahead and make the absolute value bracket here. We have cotangent x times tangent x cosine x. So this is just using the logarithmic property to make a single logarithm out of the sum of two logarithms. And then we can rewrite cotangent x as cotangent theta is equal to cosine theta over sine theta, and the other quotient identity, which is tangent theta, is equal to sine theta over cosine theta. Okay, so employing that simplification, we rewrite this as ln absolute value bracket of cosine x over sine x, and this is just replacing cotangent x, times sine x over cosine x, and that's simply replacing tangent x times cosine x. And now we have our simplification. Sine x over sine x cancel equal 1, cosine x over cosine x cancel to equal 1, and we have left ln natural logarithm of what's left, cosine x, which equals the right side. Check that we verified this identity. Go on to problem 45. And in problem 45, we have negative 2 cosine squared x equals sine to the fourth theta, instead of x, theta, minus sine cosine to the fourth theta minus 1. Well, for this one here, what we're going to do is take this right side and have it, we hope, equal the left side. So working on this right side, we're going to rewrite this sine fourth theta minus cosine fourth theta as a difference of squares. Okay, to do that, we write this as sine squared theta plus cosine squared theta times sine squared theta minus cosine squared theta. And then we bring along this minus 1. Okay? And so, having done that, we're going to just take this, we rewrite this one on the left, sine squared theta plus cosine squared theta, we can rewrite as 1. So we have 1 times quantity sine squared theta minus cosine squared theta and what we're going to do here is take this sine squared theta now, and if we remember, if we have sine squared theta plus cosine squared theta equals 1, we can rewrite sine squared theta as one minus cosine squared theta. So that's what we're going to do with this sine squared theta here. So we're going to rewrite this sine squared theta as 1 minus cosine squared theta. And then we're going to have minus cosine squared theta minus 1. Okay. So we're coming to some kind of conclusion here. And what we have is we have 1 minus 1, just kind of putting these numbers together, right? 1 minus 1 at the end. Then we have minus cosine squared theta minus cosine squared theta. So what we have left is 1 minus 1 cancel each other. So we have negative 2 cosine squared theta. And now we have fixed this right side to equal left side. Check. We have verified this identity in problem 45. Now, problem 47. Now, problem 47 really, to me, seemed to be the hardest of all these identities. In fact, this one is so involved, I'm not going to work the whole thing out, but just get to a certain place. And we're going to change this right side to equal the left side. And we're going to rewrite this secant to the 6th theta minus tangent 6 theta as a difference of squares. So we're going to rewrite this as secant cube theta minus tangent cube theta times quantity secant cube theta plus tangent cube theta. And what we have to do for this one is use a difference of cubes, which is a more obscure technique. Nevertheless, it is a technique that's taught in many Algebra 2 courses. And so to do that, we're going to rewrite this left one here, this left term here, as quantity secant theta minus tangent theta times quantity secant squared theta plus secant theta tangent theta and plus tangent squared theta times, okay, I'll put a multiplication dot, I'm going to come below here, take so much space, secant theta plus tangent theta times quantity secant squared theta minus secant theta tangent theta and that's going to be plus tangent squared theta. See how this is expanded out like crazy? Well, the next thing we're going to do is we take this secant squared theta plus secant squared theta in both these terms and replace this with a tangent squared theta plus 1. And then expanding from there, okay, and simplifying from there. And eventually comes down to being what the left side is. That's really a lot of space. I don't know if I'm going to make a separate video on this, but Very interesting problem using difference of cubes. We'll just go on to problem 49. Okay, problem 49, we have secant squared x cosecant squared x equals secant squared x plus cosecant squared x. And for this, we're going to take this right side until it equals the left side. And we're going to rewrite secant squared x as 1 over cosine squared x. And we're going to rewrite cosecant squared x as 1 over sine squared x. And then what we're going to do now is make a common denominator of cosine squared x, sine squared x. And doing that, I'm going to write this cosine squared x, sine squared x. And in the numerator, what we have is cosine squared x plus sine squared x. Okay. And it's almost like I actually kind of wrote it in the wrong order. I think I should have written it as sine squared x plus cosine squared x, but this operation we can make by getting a common denominator. Well, what we can do is we can rewrite this numerator here, cosine squared x plus sine squared x, as 1. So we have 1 over cosine squared x, sine squared x. Well, secant x, right at the top, or secant theta is 1 over cosine theta. And cosecant theta is 1 over sine theta. And so using these two reciprocal identities, we can rewrite this expression as 1 over cosine squared x is secant squared x, and 1 over sine squared x is cosecant squared x. And so now we've successfully made this right hand equal to left hand, so we verified this identity. So anyway, these are the odd number problems. Problem 47, we didn't get all the way through that. I may eventually make a separate video on that, being a longer exhibition of using trigonometric identities. Good luck on these other problems, and thanks for viewing.